Hello, so today we are going to do this problem called substring with concatenation of all words. So the problem says is that we have a string and array of words that are the same length. So this is important, same length here. And we want to return all starting indices of S in S basically, such that those substrings are concatenation of all the words in words. And this concatenation can be in any order, right? And so what this would mean here, if we take a look at this example, the different combinations of these words is foo bar or bar foo, right? And so we have bar foo once here, so starts out at index 0, and then we have foo bar that starts out at index 9. If you count, you would find that this here is 9. If we take a look at the second example, right, we are looking for a combination of these, so either word good best word or good word best word, and then all the different permutations. And if we look at this here, the problem is here we have two successive goods, but that's not like a combination. We want each word to occur only once. This here we have all three, but the problem is that there is good repeated 2 times before getting word. Right, so we need the combination we need is word good best word, but that doesn't work because there is these two in between. So that's why we wrote an empty list, because there is no substring like that. If we take a look at the last example, bar foo the, we have it here, foo bar, this one first and then this and then this, and we have it here as well. Okay. And then it seems like we have, so this one starts out at 6, this one starts out at 9, I think, no, this one starts out at 12, and then where do we have the second one? Yep, we have a second one here, bar the foo, right? So this one is the one that starts out at 6, this was the one that starts out at, this one 9, and this one 12, right? So we have 3, that's what we written here. We return the indices of the start of the substring occurrence. I hope that was clear. Now let's see how we can solve it. Okay, so let's see how we can solve this. So one thing to note in the problem statement is that it said that each word in the list of words each word in the list of words has the same length. Okay. So that's one statement. So what this would mean is that what we are looking for overall, the sides of the concatenation, which is the concatenation of all the words, but in each time in different orders, that's just the size of all the words, right? And since we have, let's say, words, right, then if we consider, let's say, word length to be the length of the first word, right? So if we consider that to be the length of words 0, the first word, then actually what we are looking for, let's call it size, is just the word length. Since each word has the same length, it's multiplied by how many words we have. So the length of all the words, right? Because let's say we have 4 words, right? And the first one has length 3, right? Since all of them have the same length, that means we have overall, if the concatenation has length 3 by 4, 12, right? And that's exactly what we are doing here. So this is what we are looking for, right? So what we can do is just look, and then we have our string S, like this. So we can look for I, starting from position 0, all the way to I, to the length, n minus size plus 1. So this is n. Why? Because, well, this here is smaller than, let's take this, maybe it's n minus size minus 4, this index here. If we start from this index, we won't have enough for all the words concatenation, so that will never be a valid substring, and so we don't need to look past this position here. So that's the first thing. We can take I just from this position, from 0 to this position, n minus sz, and this here, so one thing to note here, +1 is needed only in Python, because to get to the last one you need range up into n minus z plus 1, but really concretely it's n minus size. That's what we are dealing with here. Okay, so that's the first observation. Now the next thing, how do we, for a substring, we have a substring that is a possible candidate. Let's call it a candidate substring. How do we determine if it's in S and get its index, right? So let's call that presence or check presence, something like that. Okay, so check presence starting from one of these positions. Okay, so how do we do that? Well, what we can do is just look at each word, look at each like range of word size, word being just, let's say if we had again 3, look at each chunk of 3 characters and check if it's one of these words, right? If it is, it means we continue searching. If it isn't, we shouldn't check, right? If it isn't, let's say this is foo, bar, the, and maybe car, right? If we find, I don't know, level or something, string, or actually we need something of length 3. If we find, let's say, sky, then we should stop, right? Because in that substring, that would never be a valid solution, so we should break. So that's the first thing. The second thing is, what if we have actually in our list of words, what if we have foo, and then bar, and then car, something like this, right? We have foo 2 times. That means in the substring that we are looking for in the string, we need to have it 2 times as well, right? So for this actually to be easy to determine, we can use a counter, or you could use a map that counts how many times each word occurs in the list of words, just so that we can make sure exactly that number occurred. So in Python we can use a counter for this. Okay, so those are just like a couple of ideas that will keep surfacing. Now, how do we tell that we have the substring, that one of the concatenation exists, right? So the way we are going to do it is we're actually going to take every substring of length size, which we are looking for, and check if all the words in W are in it. That's what we are going to do. So basically, for each substring of size, the size we are looking for, of length size, check if all words in W exist in it with the same number of occurrence number or occurrence count. So that's what we are going to do. So the easiest way to do it is to have the counter for how many times it occurs, and each time we find that word, that subword, decrement, right? And count how many words we found, and at the end check if the number of words we found is actually equal to the length of words, which would mean that that it's a substring, right? So how do we do that? Well, let's say we have word count, right, for each. So this is just for the check presence function, so let's define that a little bit here. So check presence starting from a position I. How do we do that? We need a word count, right? So let's call it WC. This would be the word count, so we can have it be the counter for all the words, right? This will give us basically, if foo is occurred twice, it would be like this. If bar occurred once, it would be like this. And you get the idea. So if we have that, then so once we have this, then we need to see how many words we found, right? So initially it's 0, and at the end we want to return if we found. How do we check if we found all the words, right? Well, as long as we have the size, right? Let's say we have here 5. We need to make sure we have 5 of them. So if we have 5 of them, that means we found them. So this will be, it needs to be equal to the length of words. Now, how do we check? We have an index, right, in S, and we want to check if it's if this is a valid substring that contain all the words. So let's just go through each chunk here, right, of length. What should be the length here? The length should be the length of the word, so it should be word length. So go through each chunk of size. This would be of size word length. This is just the length of the first word because they all have the same length. And check if this is in W, but because we may have like a double foo, let's say maybe we need like we have a list of words like this. Well, each time we find it, we will need to decrement it from the counter, right, to determine that we exactly have that many words, right? So to do that here, what we can do is just do a for loop and go through the range. Remember, we are looking block by block here. So we need to go from the first index we are looking for, and each time look at the entire block here, which we said it's so we need to each time look at one block, but we need to look at all the length of a possible candidate, which is the length of this here. What we said is the size that we are looking for. And so size here, and each time we want to look at a block of word length. Okay? Now, what is the substring for this here? The substring would be equal to S from J to J plus the word length, right? Because remember, this is just one of these blocks, right? Okay. And now what do we want to do? We want to check if it exists in the list of words, because if it's sky, it's not in the list of our words, so we can exit. So we want to check if it is. How do we check with the counter? We just make sure this substring count is bigger than 0. But if it doesn't exist, right, or maybe in the substring we have foo, let's say 3 times, but we need it only 2 times, so now the count would be -1, then we want to exit. So here we want to exit if that's the case, so that we check the return. No need to proceed because we know this substring is not valid, right? But if it is, then we want to subtract it, right? Because once we found foo, we want to subtract that we found it. And so we want to decrement by 1. Let me just leave some space here. Okay. The other thing we want to do, because we found this substring, so we want to increment how many words we found. Because at the end we want to check that we found all of them. Okay? And that's pretty much it. So again, to reiterate, we'll do the first loop that checks, goes through every index in S from I to n minus size, right? Because those are all the possible valid substrings. So we'll check, let's say the size is maybe 5. So we'll check this, and then we'll check this, and then we'll check this, until here, because there is no possible string of length size, right? And size is all the length of all the words combined, right? And to check for each individual candidate if it's a valid concatenation, we take the word counter for it and we count all the words we find. But in order to count it, to make that more efficient, we look block by block, and the block is just a possible word, right? And we check if that word exists. If it is, we count it and we subtract it so we don't count it again. And if we don't find it, right, that means that substring is not valid, so we can just exit, and then this will fail, right? But if we go all the way to the end of the substring and we found all the words, that means it's a valid concatenation, so we would check if the length would be equal to the length of words, and we would return that it's valid. Yeah, so that's pretty much the idea here. Now let's code it up and make in Leetcode and make sure it passes test cases. Okay, so let's write the full code that we are expecting here. So we want to return the indices, the possible starts. So we check all the possible starts here. And this is n minus the word's size, or what we called size in the overview. We do +1 here so that we look at this as the last possible index, right? And we need to define a couple of things. We need to define n as the length of the string. And we need to define words size as the number of all words, right? So that's like this. And now we check presence of all the words starting from that index. If we found it, that means this index is a valid start of a valid concatenation, and so we add that index, and then at the end we return it. And so now it's just about writing the check function, and we already wrote that in the overview, so we can just use that here. And so overall, what we are doing here, we used collections counter for the words, so that we have the count of each word. And then we check the found, and then at the end we check that all the words found is the length of words, which means we found everything. So here, this is just the length of words. Okay. And then we just to reiterate again the check we are doing, we start from I, and we start from I, and each time check a block of length, the length of one word, right? And we do it until all we traverse all the string we are looking at. So word size, I know this is a little bit confusing. So word size is actually the length of the first word. So that's word. Yeah, let me just make sure. So this is the length of one word, right? And this is the overall word size. So let's just make this named size. So this would be the length of all number of words multiplied by this. So this is the size candidate. And that's what we are looking for here. And we have, this is the word's length. So this is the number of words we have overall. So this is what we are multiplying by. Okay, let's maybe make this easier to understand by naming it number of words. Okay, and then check this here. And here, just make this super clear, single word length. So this would be single word length here, right? That's what we are looking for. And here we go through the counter. If it's equal to 0 or less than 0, that means this is not valid. Either the word is not there or it's there more times than needed, and so we break. And then we subtract once we found it and increment the words found. So that's the main idea here. Now one thing we can optimize here is we are doing counter for words each time, right? And so what we can do is define it here. So word count, call it. But the problem is that since we subtract from it, once we do it for one iteration here, we don't want to carry over what we deleted, right? We don't want to carry that over, so we need to use a copy. So here we use a copy like this. Okay. Yeah, so that's the main thing here. I hope this was clear. So let me run this, make sure it works properly. So we need to define this function with the same name. Okay, let's try to submit. Okay, so there is one error here. Let's check what could be wrong. Yeah, so the problem is that this should be the length of one word multiplied by the number of words, right? So let's run this again. Okay, so that looks better. Okay, so that passes test cases. Yeah, so I think that's pretty much it for what I wanted to cover for this problem. You can also solve it with the sliding window technique, where the idea here is that each time here we do, we go I one by one, right? The one by one, but there is a lot of information lost. Like maybe, let's say, for example, let's take this here, right? If you take a look, we first do this, right? There is the information that this one is present, right? And so we could just start looking from here. We don't need to repeat from this index. And also, like with this here, let's say maybe we have I don't know, like a word sky in the middle here, right? Once we find that sky is not there, a character S is not there, then why, like sky, there is no K and Y, so why check K next to it, right? So it doesn't make sense. So basically take advantage of the information you have so far to make the implementation more performant. And you could do that with a sliding window technique. But I think that solution is slightly more complex, so I would go with just this simpler one. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.